So in our last lesson of this unit, we're going to take a look at solving quadratic inequalities. Now you know how to solve a linear inequality. You saw those in Algebra 1. Quadratic inequalities are a little bit different. So what I want to do before we actually get into the solving is give you a visual of what it is that we're trying to do. So think about your coordinate plane. And when we graph a quadratic equation, it looks something like this. We know that this quadratic equation opens up because the lead coefficient is positive. If that x squared had a negative coefficient, it would open down. Now notice we're looking for where the quadratic is less than 0. So we're looking for this part of the graph right here, where it is below the x-axis. So keep that in mind as we solve. So the first thing we need to do is find where it equals 0. So we're going to factor x minus 3x plus 2. This is t-chart, what multiplies to negative 6 and adds to negative 1. Now I said it equal to 0 because we're trying to find those x-intercepts. We'll go back to the inequality once we have these solved for. So we set x minus 3 equal to 0 and get x equals 3. X plus 2 equals 0, so x equals negative 2. So we're going to set this up on a number line. If my page will extend. And if you look at my picture, it looks like it's going to be in between the x-intercepts, which is most likely the case. However, what I want you to do is check all of the boundaries. So we are going to check all of the values below negative 2, not all of them. We are going to test one in between negative 2 and 3, and one greater than 3. Now I used open circles because it is less than 0. So negative 2 makes it equal to 0, so it's not part of the solution. So let's see what happens if we substitute negative 3 into our inequality. We would get negative 3 squared is 9, plus 3, minus 6. So 9 plus 3 is 12, minus 6 is 6, which is not less than 0. So based on our graph, we are correct to assume that that's not going to work. If we substitute 0, we get negative 6 is less than 0. That is true. So we're going to shade it in between negative 2 and 3. And just to double check, we're going to substitute 4. So we'd have 16, minus 4 is 12, minus 6 is 6, which again is not less than 0. So the solution set is numbers between negative 2 and 3. And actually, real quickly before we move on, let's also use set notation to revisit what we did that first unit, because you're much more familiar with interval notation. So two ways to express our answers would be negative 2 is less than x is less than 3, or using set notation, negative 2 to 3, using parentheses because neither of those are included in the solution. On this one, we do not have it equal to or an inequality around 0. Anytime you're solving a quadratic equation, you want to get it equal to 0. So I'm going to subtract 9 from both sides. And we're going to set it equal to 0 because we have to find those x-intercepts. Factoring, we get x plus 5, x minus 1. So our two boundaries would be 1 and negative 5. So setting up our graph. Again, this time we're going to use closed circles because negative 5 and 1 will make the inequality true. Substituting negative 6 into our inequality, we would have 36 minus 24, which is 12, plus 4, which is 16, which is not less than or equal to 9. So similar to that picture we had on the first one, looks like we're going to get in between. 0 is always a nice one to try. Substitute that one in. 4 is less than or equal to 9, so we're good there. And just to double check, because sometimes you make a mistake when you solve. So if you double check all 3 intervals, you'll catch your mistake most likely. So if I substitute 2 in, I get 2 squared is 4, plus 8 is 12, plus 4 is 16, which again is not less than or equal to 9. So to represent our solution with inequality notation, negative 5 is less than or equal to x, which is less than or equal to 1. Or using set notation, This time the solution is included, so we use the brackets. One final example. This time we have a quantity squared greater than or equal to 1. So again, we're trying to find where it equals 1, so we can just go ahead and take the square root of both sides. Careful when you take the square root, there are two answers. X minus 3 equals positive 1, or x minus 3 could be negative 1, because once you square it, it would become positive. So make sure you set up both equations. You should always have two solutions when you're solving these quadratics. Adding 3 to both sides, we get our boundary points to check. So we have 2 and 4. It's an or equal to, so these are both shaded in. Checking 0 for a number less than 2. 0 minus 3 is 3, squared is 9, which is greater than or equal to 1. Checking 3, the only integer between 2 and 4. 3 minus 3 is 0, squared is not greater than or equal to 1. And if we substitute 5, 5 minus 3 is 2, 2 squared is 4, which is greater than or equal to 1. So this time, when we represent our solution, we would have to say x is less than or equal to 2, and x is greater than or equal to 4, using interval notation. Using set notation, we would say from negative infinity to 2 inclusive, union 4 to positive infinity. And your U-try question.